করতে আর কি। এটা এখনো ডিসাইড করিনি যে আমাদেরটা কিভাবে পরীক্ষা হবে। হ্যাঁ, অনলাইনে হতে পারে, অফলাইনে হতে পারে।
ওকে স্যার। স্যার আমাদের সিলেবাসটা কি মিডের পরের গুলো থাকবে, টপিক গুলো?
হ্যাঁ, মিডের পরের টপিকগুলো। মানে মিডে যেগুলো সিলেবাসে ছিল না আসলে সেগুলো, আর মিডের পরে যেগুলো পড়াচ্ছি সেগুলো।
স্যার মিডের আগে তো স্যার পিসিএ পড়াইছিলেন, ওগুলো তো ইনক্লুডিং ইন ফাইনাল সিলেবাস।
হ্যাঁ হ্যাঁ হ্যাঁ, ফাইনাল সিলেবাসে ইনক্লুডিং।
ওকে স্যার।
Okay, I think we can start our today's lecture. So today the lesson is about clustering, specifically the algorithm K-Medoids. So we have already discussed about the K-means clustering algorithm, but it has some limitation, okay, and therefore several other clustering algorithms are also proposed. At first, we need to understand that why we need the K-Medoids, or you can say why K-means algorithm is not enough. Then what's the problem in K-means algorithm? So before selection of different models, we need to understand the drawbacks, and also we need to understand the strengths of any algorithm. So therefore, at first I want to discuss about the problem in K-means algorithm. The K-means algorithm, we know that there is K-means, that means usually the centroid, or you can say center of the cluster, is determined by averaging the values of that cluster. So it has some limitation. Okay, the limitation is if we do clustering or determine the cluster center based on the average value, then those kind of algorithm will be very sensitive to the outlier. That means the cluster center, it will sensitive to the outlier, or we can say the cluster center will be inclined or maybe biased towards the outliers. What's the outlier? Outlier usually we call those values, those are not within the range. Like we can say that the human age. The human age, maybe you can say 100 maximum. Maybe you can say 105, 110 maximum. Okay. But if you can see that the age, someone mentioned the age is 1000 years, 900 years. So that means those values are actually kind of outliers. Okay? That is, those values are not within the range. Similarly, maybe you can say there is some sensor values. You can observe some sensor values, but for some reason, the sensor also can produce some out of bound results, and those are maybe you can say below or above the range. So those are also, we can call it outliers. But if there is any outlier in data set, then the K-means algorithm will not perform well, or we can say it will always bias towards the outliers. Why? Because it is just doing the average. So we can say that maybe you can say uh, we have a cluster. Maybe we have a cluster like 1, 4, and another value it is mentioned like maybe the 100. So if we can say that this 100 is our outlier, then if we find out the average of these values, then it will be 1 plus 4 plus then 100 divided by 3. So to find out the center of this cluster, we have to do like this way. So that means 105. 105 divided by 3. So it is 35. It is 35. Okay, 35. Actually, this 35 value is because of this large number. Because of this large number, that is 100. Because of this large number. Otherwise, if we can see that if we can say that these are our legitimate values, or we can say within the range values, then the center, we will find the center maybe nearly 3 or 2 like this. But we can see that because of the outlier, instead of 3 we got the average is, that is the center is 35. So that's unusual, or you can say very much biased towards the outlier. So that's the problem in K-means algorithm. That means if in your data set we have some sort of outlier, there are some methods also for outlier detection and also outlier elimination. Okay, so if we can do that, then K-means is fine. Okay, K-means is fine. So to eliminate this problem, that means the biasness problem, one of the method, a clustering method is proposed, that is called the K-Medoids cluster. So in K-Medoids clustering, we will not determine the mean value. Okay, we will not determine the mean value for finding out our center, cluster center. So what we will do, we will try to find out the reference point, or we can say most centrally located representative object or representative points. So these most centrally located representative points, usually we call it medoids. Okay, that means in case of K-medoids, we will not find any maybe we can say any average value, or we can say any new number or new data point. We will not form any new data point. Within our data point, we will try to find out the most centrally located representative point. Okay, that's the K-Medoids, the philosophy of the K-Medoids. Like here in this case, we can see that consider that we have this data set, and if we can find out that like maybe this is just one cluster. So if we apply K-means algorithm, then the center of this cluster will be a new point. Like maybe you can say if we find out the average of this data point, maybe you will get here. Maybe at this this will be the center, maybe. Okay, and for another cluster, maybe this is our another cluster, and for if we want to find out the center using the K-means algorithm, or averaging out the values of this cluster, then maybe you will get the center here. Okay, you will get the center here. It means that the center is not a point within our data. So the center is a point that is a new point created by the algorithm, the K-means algorithm, in K-means clustering algorithm. But in case of our K-Medoids algorithm, so it will try to find out, it will try, instead of that is creating a new data point, it will try to find out a new, it will try to find out the most centrally located point. So maybe for this cluster, it will try to find out, okay, this is maybe this data point is most centrally located. So this is our K-Medoids. For this cluster, maybe you can say this is our most centrally located data point. So this is our medoid. Okay. So in this way, K-Medoids will try to find out centrally located objects within our data points or within our data sets. It will not create any new data point on that case. Okay. So now we want to discuss about the steps in our K-Medoids algorithm. So at first, the first step is we have to determine how many clusters you want. So maybe you want 2 clusters or maybe 3 clusters like this way. Or you can also determine the optimal cluster, possible optimal clusters using the elbow method, or we can say using the Shilhouti score, okay, some other methods or algorithms we have also. Consider that anyhow we determine the number of clusters, like we want just 2 clusters here. So here the 2 clusters, that is the del of k equal 2. Now, what we have to do initially, we have to select 2 data points from our data as Medoid 1 and Medoid 2. Why 2 Medoids? Because we want just 2 clusters. Okay. So randomly pick. We can maybe any of the point as Medoid 1 and another point as Medoid 2. Same like the K-means algorithm also. So let's say initially we can say that this one is our Medoid 1. This is our Medoid 1. And this is our Medoid 2. Okay, so this is our Medoid 2. Initially, we can say that this is our Medoid 2. So Medoid 1 and Medoid 2 are there. Okay, now, so here, this is our Medoid 1 and the Medoid 2 is this. This is our Medoid 2. Now, what we have to do? We have to find out the distance from each and every non-Medoid object to our Medoid, or you can say to our cluster center. So here, this is our Medoid 1 and this is our Medoid 2. So all these are just non-Medoid objects. Consider that this is the name of this object is A, data point A. So from this data point to Medoid 1, we have to find out the distance. From this data point to Medoid 2, we have to find out the distance. Okay. Now, based on the distance, we have to assign this A either in cluster 1 or in cluster 2. Let's say this is our cluster 1 and this is our cluster 2. So now whether I need to put the A in cluster 1 or cluster 2. So now we can see that the distance from A to M1, it is smaller than the distance from A to M2. So that means M1 is closer to A. So A we have to assign in cluster 1, that is in Medoid 1, okay, cluster 1. So A we have to assign in M1 or cluster 1. Then let's say we have another data point like here the B. And now B to M1 we have to determine the distance and B to M2 we have to determine the distance. And we can see that B is closer to M2, okay? So B we have to assign to our cluster 2. Similarly, another point is C. So we have to determine the distance from C to M1 and C to M2. Now we can see that C is closer to M2, so that we have to assign C to our cluster 2. So in this way, for all other data points, that means we have to, based on the distances, we have to assign either in cluster 1 or in cluster 2. Then we will get the clusters. Okay, we will get the cluster 1 and cluster 2. Like in this case, maybe you can say that we get the cluster, like maybe we can say this is in one cluster and those are in another clusters. Okay, another cluster. Now what we have to do next thing is we have to determine the cluster cost. Okay, formation of cluster of C1 and formation cost of formation of cluster C1 and formation of cluster C2. By combining the cluster cost, we will get the total clustering cost for these two clusters. So how to determine the cluster cost, I will discuss it just after a few slides. So consider that at this stage, you got the cluster cost 20. The cluster cost is 20. So anyhow, you determine the cluster cost and that is 20. Okay, so next what we have to do, okay, you already find our, that is the output of our initial clusters. Okay, initial cluster you got, and also you determine the cluster cost is 20. Now we have to continue for next iteration. Next iteration. In our next iteration, what we have to do, uh, we have to change one of the medoids. So we have to change one of the medoids, or we can say we have to swap one of the medoids with non-medoid objects or non-medoid instances. So here in this case, we can see that we have this one is our medoid 1 and this one is our medoid 2. So now either M1 or M2 we need to swap with non-medoid objects. Then what are the non-medoid objects? The cyan color, actually the cyan color objects are our non-medoid objects. Okay, cyan color rectangles are the non-medoid, and we can say blue colored are our medoids. So any of the non-medoid. Let's say in this case, I have assumed that okay, I want to change or I want to change the M2. Okay, I want to change the M2 with any other non-medoids. So here I have considered that this is our M2, new M2. Okay, this is our new M2. So previously this one is the M2, this one is M2, but it is not now considered as the medoid. So new medoid, we can consider this one. But M1, I just kept it as it is. Okay, so I just kept it as it is. Okay, now we can see that new medoid is here. This is new medoid, and now again, what we have to do? We have to determine the distance from each and every instance, from instance A to M1 and instance A to M2, the new M2. Okay, the distance, and based on the distance, I can assign maybe A to cluster 1 because A is closer to M1, so A to cluster 1. Now, from the B, I need to again determine this from the B to M1 and then B to M2. So maybe this time we can say M1 is closer. So B, we have to place at cluster number 1. And then maybe you can say another object is C. Another object is C. C to M1 and C to M2. We have to determine, and we can see that C is closer to M2. So here is M2. In this way, we have to that is determine the distance, and based on the distances, we have to place those instances either in M1, that is cluster 1, or in M2 or in cluster 2. So maybe after maybe assigning the elements in different clusters, we will found like maybe the cluster like this. So that is in one cluster we will get these 3, and in another cluster maybe we will get these elements. Okay, elements. And again, what we have to do, we have to determine the cluster cost. Let's say the cluster cost at this stage it is like 18. It is 18. Cluster cost is 18. So now we can see that from 20 it is 18. So that means cluster cost is reducing, and we want to minimize the cluster cost. Okay, the cluster cost is reducing. Reduced cluster cost means compact clusters. So that means we can see that 18 here, it is reduced cluster, or you can say compact clusters, or we can say improved clusters. So we will not stop here. We have to, as it is reducing, we have to go forward. Okay, that means we have to move forward.
Sir,
Uh,
is this cost for one cluster or combinedly two clusters?
Two
Cost.
clusters total.
Okay, 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 sir.
Okay. So now what we have to do, we have to maybe go to the next iteration. And in this iteration, again what we have to do, we have to swap any of the midwives. Okay? So previously this one is our M2, and this one is our M1. This one is our M1. Okay, so this one is our M1. Now I want to swap the M1 with some other elements. Okay, like so this time maybe I can consider that this is my M1. So this is my M1. So this is no more our M1. Okay. So now again I have to determine the distances from each and every elements, like from A to M1 and A to M2. Okay, so A to M1 and A to M2, and maybe M1 is closer, so that is the C. In C we have to assign A, and from the B you can see here from B to M1 and B to M2. Okay, maybe C2 is closer, then we have to again assign here B. Then maybe for the C you can see the M2 is C is M1 is closer, so C we have to place it here. Okay, so in this way maybe we will get clusters. Okay, we will get the cluster. Now again we can see that based on, maybe we will get the cluster, and we need to determine the cluster cost for C1 and cluster cost for C2, and we need to combine those cluster cost. Maybe this time you will get the cluster cost is 26. So we can say it is increased. Okay, so previously it was 18, but now we can say it is 26. So if we got something that is increased cluster cost, we have to stop there. We have to stop there, and then we have to go back to our previous iteration, and whatever the clusters we got in our previous iteration, we will produce that one as the output of basic K-Medoids algorithm. Okay, so that means when we got the increased cost, then we have to stop there. The basic K-Medoids algorithm will stop there, and then back to the previous step, and then whatever the clusters it will find, and that will be the output of basic K-Medoids algorithm. So that's the
Sir,
procedure here. Yeah, please.
in the step when we are selecting a new cluster for our cluster 2, do we intentionally avoid the previous clusters?
No, no, it is just random. Okay, so any,
Purely random.
yeah, purely random.
Okay.
Okay. So here's one big disadvantage, or you can say demerit, is this, that is K-Medoids algorithm, the basic K-Medoids algorithm, it will not actually produce the optimal cluster. So that's the big problem in K-Medoids algorithm. It will not provide you the optimal cluster, but the near optimal. Okay, it will provide you the near optimal solutions. Uh, but there are some ways to
Sir, I have
find
a
out
question.
the optimal clusters
Change
based on
two
our
meteors at a time.
K-Medoids algorithm. Hello?
Yes, sir. So can we choose change two meteors at a time or just
No,
I?
no, just one midwife at a time.
Okay, sir.
Okay, so we have the way to find out that is optimal cluster also, but it will be expensive, specifically you can say time and space competitive. In both of the cases it is expensive. So I will also discuss about that, how to find out that is optimal clusters. Okay. So that's the procedure. Okay, so we will follow this procedure. So let's say we have a data set. The data set is given. This is the data set. And in this data set, you can see we have 0 to 9, total 10 instances in our data set. Okay, total 10 instances and two features. The given X and another feature is Y. So two features we have. And as clustering is unsupervised approach, so there is no class level. Okay, class level is not given. And again, based on our data set, we want to form 2 or 3 clusters. Okay, so here in this example, I assume that I want to form just 2 clusters, and then that means that the value of k is 2. The value of k is 2. Okay, value of k is 2. The next thing is we have to randomly select 2 medoids. Randomly select 2 medoids. So you can consider any of our instances as medoid 1 and as medoid 2. So here we can I assume that maybe this one is our M1, that is medoid 1, and I also assume that this is our M2. This is our M2. Okay. So it means that in this graph, if you can see that there is 3 4. Okay, so 3 4. So this is our medoid 1, and another is M2 is 7 4. Okay, so 7 4, and this is our medoid 2. Medoid 2. Okay, so the initialization, this is our initialization. Now what we have to do, we have to actually consider each and every instance and determine the distance. Like if we consider this is our 0 instance, or you can see instance number 0, I0. From I0 to determine, we have to determine like M1, and from I0 to M2, we have to find out the distance. I0 to M1 and I0 to M2. If we consider this is our I2, I1, then we have to find out like from I1 to M1 and I1 to M2, like this way. Okay. So now we have M1 and M2, and we have to determine the distance from each and every instances to M1 and M2. So like here we can see that we have computed the distance in this case. So this is our M1 and M2. Okay, so that means distance from individual 0 to M1, and we know that this is our M1 and our M2 is this. We have considered this is our M2, medoid 2, and the vector values are 3 4. So that means M1 is our 3 4, and M2 is 7 4. Okay? So here it is 7 4. M2 is 7 4. Now we have to determine the distance. Okay, so distance, that means we have to use some form of distance function. It can be Manhattan distance, it can be Mahalanobis distance, it can be cosine similarity, it can be Euclidean distance, Hamming distance. So that means one type of distance function we have to use here. And in this example, I have used the Manhattan distance. The Manhattan distance is easy to compute. So what we want to do, so we want to compute the distance from instance 0. So instance 0, from instance 0 to M1 and instance 0 to M2. Instance 0 means the vector for that is, this is our instance 0 vector, that is 7 6. So we can say that here is the instance 0. From instance 0 to, I want to compute the C1. Okay, C1. Here instance 0 is 7 6. Directory elements is 7 6, and C1 is our C1, or you can say there is M1. C1 is our M1 3 4. Okay, 3 4 3 4. So if we want to compute the distance, then it will be using our Manhattan distance function. So here is the 7, here is the 3, so that means it will be 7 minus of 3, absolute value of that, plus of then 6 minus of 4, 6 minus of 4, and absolute value of that. So 7 minus of 3, the absolute value is 4, and 6 minus of 4, absolute value is 2. So 6 minus 4, absolute value is 2. It is 4 plus 2 is 6. Okay, so it is 6. So you can see here it is 6. Similarly, we want to compute the I0 to C2. Okay, so C2, or you can say M2, cluster 2. Here I0 to C2. The C2 in this case we can say M2 is 7 4. Okay, 7 4 7 4. Then the distance, if we want to compute the distance, it will be here 7 6, here is 7 4. That means it will be 7 minus of 7, absolute value of that. So that means you can say this. So here is the this 7 minus of this 7. Okay, absolute value of the plus of 6. So here is the 6, and then here is the 4. Okay, so that means 6 minus 4, absolute value of that. Then we will get 7 minus 7 is 0, 0 plus 2 is 2. It is 2. So we can see here is the 2. So similarly, we have to compute the distance from I1, like here the I1, and the vector values for I1 is 2 and 6. If we calculate the Manhattan distance from I1 to M1, then we will get the 3. If we compute the Manhattan distance from I1 to M2, C2, it will be 7. Okay. So in this way, we will get the distance from each and every individual to M1 and M2. Okay. So these are the distances. You will get those are the distances. And now what we have to do, the next is, so we already got the distances from different instances to centroid 1 and centroid 2. The next thing is we have to now determine the cluster, we have to assign elements to the cluster. So here is, you can see C1, here is our C2. Now we have to assign members to our clusters. I0, where we have to assign I0. We can see that I0 to the C1, the distance is 6, and I0 to C2, distance is 2. Which one is minimum? The minimum one is 2. Okay? Minimum one is 2. So this is minimum. It means the I0 we have to place in C2. Okay, we have to place I0 to C2. So this means 0. We have to place here in C2. Then I1. You can see here the distance from 1 to M1 or C1 is 3 and M2 is 7. The minimum is this one. So that means I1 we have to assign in C1. Then consider the I2. The minimum distance is this one. So that means 2 we have to assign in C1. And then 3, the minimum distance is this one. So that means C2. So 2 is closer. The 3 we have to assign in C2. 4. 4 we can see this is 0. So that means 4 C2. So 4 is also in C2. Then 5. Here is the 5. 5 you can see the minimum distance is 4. So we have to assign 5 in C1. Then 6. Minimum distance is 3. We have to assign 6 to C2. 6 to C2. And then 7. Minimum distance is 1. So 7, that is C2. 7, C2. And then 8. 8 is here. 8 is also C2. And then 9, it is 0. So 9 is 0. That means 9 we have to assign in C1. Okay, so that means assignment is done. So the member assignment is done. So now we can see in C1 we have 1, 2, 5 and 9, and C2 we have 0, 3, 4, 6, 7 and 8. These are the instances in C2. So after cluster assignment, what we have to do? The next thing is we have to determine the cluster cost by combining the cost of forming cluster of 1 and forming cluster of 2. So how to determine the cost? So for the cost determination, consider that the cluster 1 first. So the elements of the first cluster is the cluster element 1. Okay, so that means 1. So here is the 1. Here is the 1. And we have to add the minimum distance to determine the cluster cost. So minimum distance from 1 to C1 and C2, which one is minimum? The 3 is the minimum. Okay, so the minimum distance here is 3. So that is 3 plus. Then another element is 2. So 2 is this. The minimum distance from 2, we know that is 4. So here is the 4 plus of then 5. So 5 is there. From 5, we can say minimum distance is 4. Okay, so here is 4. And in cluster 1, we have also 9. That means the 9 distance from 9 to C1 is 0. Okay, so we can maybe consider that one also. You can see here it is 0. Okay, so this is the cost of our forming cluster 1. Plus, we have to think about determination of cluster cost of cluster 2. So for cluster 2, the first element is 0. So here is the 0. And the minimum cost is 2. So here is the 2. Plus. Plus. The next element is 3. You can see here this is 3. And minimum cost is 2. Okay, first minimum cost is 2 plus the next element is 4. So element 4. So element 4 the minimum distance is 0. Okay, so here is the 0 plus then 6. Then 6 minimum distance we can see it is 3. So here is the 3 plus then 7. The minimum distance from 7 is 1. So here is the 1 plus of then 8. From 8, the minimum distance is also 1. So here's the 1. So if we add these two, then we will get the 20. Okay, we will get the 20. So that means the cluster cost for forming these two clusters, it is 20. So we have determined the cluster cost. The next thing is, that means we already complete the first iteration, and we got the set of clusters. In C1 we have the elements 1, 2, 5 and 9, and C2 0, 3, 4, 6, 7 and 8, and also we determine the cluster cost, that is cost is 20. Then we have to prepare for the second iteration, and for the second iteration what we have to do, the first thing is we have to select either M1 and M2 for swapping. That means we have to swap any of the medoids with a non-medoids. Okay, so the non-medoids and medoids, to determine the non-medoids and medoids, we can see that 4 is considered a medoid and 9 is also considered a medoid. So all others are just non-medoids. Okay. So usually we use a flag for determining that is our uh, medoids. Okay, for recognizing our medoids. So like here you can see we can add a flag for medoid, usually called flag for medoid. Okay, and in this case we can see there is 9 is medoid, so we can say it is 1, and also the flag is 1. For the 4, the flag is 1 because we already considered the 4 as the medoid. And all others are 0, that is the flag value is 0 because those are not considered as medoid. So from the 0 set, that is from the non-medoid set, we have to find out, maybe we have to change just or swap or take in any value for considering the new medoid. Let's say the M2, the new M2, I can consider the new M2 like maybe 7. This 7. So this is my new M2. This is my new M2. It is also randomly picked. Okay. So this is our M2 now. M2 now, and this M2 is no more a medoid, but we have previously considered this one as medoid. Okay, that's why flag is on. Flag is 1 there. So now a new M2 is 7, so we have to add flag to 7 also. That means we have considered this one as our medoid.
FM. Is it fine for Medoids or what use? Sir, FM. What is the meaning of F?
কলামের উপরে এফএম লেবেল দিয়েছেন যে
Okay, flag. Here's the flag for medoids. মানে ফ্ল্যাগ তো আমার মনে হয় তোমরা বুঝো, ঠিক না?
জি জি
So, আমি আসলে
ইজিলি প্রোগ্রামিং এর ক্ষেত্রে আমরা অনেক সময় ফ্ল্যাগ ইউজ করি, ঠিক না?
বুঝতে পেরেছি ফ্ল্যাগ আমি
আচ্ছা
ওয়ার্ডটা বুঝতে পারতেছিলাম না তখন।
আচ্ছা, ওকে
বুঝতে পেরেছি।
ওকে। So next what we have to do. So now you can see here this one, that is 9. This one is our M1. This one is our M2. This one is our M2. So again, what we have to do, we have to consider the M1 and M2. So M1, this is M1, and then vector values are 3 and 4. Okay, so here's the 3, 4. 3 and 4, and then another is M2. Sorry, M2 is our 7 and 3. 7 and 3. So we have to determine the distance from 0 to that is C1 and 0 to C2. The similar fashion, okay? Using the similar fashion, or similar, we can say distance function, the Manhattan distance. So if we calculate the Manhattan distance from 0 to C1, then we will get 6, and 0 to C2, we will get 3. Similarly, for instance 1, the distance from instance 1 to C1, it is 3, C2 is 8. From 2, 4 and 8, 4 and 9, like this way. So that means we have determined the Manhattan distance from instance number 0 to C1 and C2. Similarly, instance number 1, 2, 3, 4, every instance is to C1 and C2. So those are the distances. Now we got those distances. And again, what we have to do, we have to form the clusters. Okay? Form the clusters by assigning members to these clusters. So in C1 and in C2. So we have to assign members. Okay, assign members based on the distances. So I0, considering the I0, we can see the minimum here is 3 is the minimum. So that means 0 I have to assign in C2. Okay, I have to assign 0 in C2. And then 1, the minimum distance is this one, that is C1. So 1 I have to assign in C1. And then 2, we can see that this is 4. 4 is the minimum. So 2 we have to assign in C1. 2 we have to assign in C1. And then 3. 3, the minimum is this. That is 3 we have to assign in C2. 3 we have to assign in C2. And then 4. The 4, you can see the minimum distance is 1. So that means 4 we have to assign in C2. 4 is here. And then 5. Here is the 4 is minimum. Okay, so 5 we have to assign in C1. And then 6. The 6 we have to assign where? 6 we have to assign in C2. So 6 we have to assign in C2. And then 7, you can see that 7 is our M2. So as this one is our M2, so the M2 must reside on C2. Okay, so that means M2, that means C2. Okay, so that means the distance between M2 and C2 will be 0. So the 7 must be in C2. And 8, minimum distance is this. So 8, you have to place 8 in C2 also. And 9, 9 is our M1. The M1 must be in C1. Okay, so that means these are the clusters here. We already assigned members to those clusters in C1 1 2 5 9 and C2 0 3 4 6 7 8. So now what we have to do again, we need to find out the cost of clustering. Okay, we need to determine the cost of clustering. And for C1 we can see here, for 1, this is the 1, the minimum distance is 3. Okay, so here is the 3. Okay, we can see here is the 3. And then the next one is 2. So here is the 2, and minimum distance is 4. So this is 4. And then next is 5. So here is the 5, and 5 minimum distance is 4. So here is the 4. And then 9. The 9 is our M1. So the distance must be 0. Okay, so we can add, or maybe may not add the 0 here. And then for the C2, the cluster 2, the 0, the first element is 0. So first element is 0 and the minimum distance is 3. So here is the 3. And then another, so here is the 3. Okay, so minimum distance is for 3, the minimum distance is 3. So here is the 3. And then 4. For the 4, you can see for the 4, minimum distance is 1. So here is the 1. And for the 6, the minimum distance is 2. So here is the 2. For the 7, we can see 7 is our M2. So M2 to M2 is 0. Okay, M2 to C2 is 0. So that means we can add or maybe or may not add. And 8 is 2. So here is the 2. Okay, so that means we can see the total distance, the total cost. The total cost is, in this case, it is 22. Okay, 22. The total cost is 22, and in our previous iteration, the cost it was 20. So from 20 and now it is 22. So that means the cost increased. If the cost is increased, then what we have to do? We have to stop here. The basic K-Medoids algorithm will stop here. The cost is increased. That means we can say, in another word, we also say this one is a swap cost. Swap cost, that is present cost minus the previous cost. So we can see swap cost is positive here. If swap cost is positive, that means it is increasing. Okay, so we have to stop here, go back to the previous iteration, and then whatever the clusters we got there, that will be the output of basic K-Medoid clustering algorithm. Okay, but if we got here that is a smaller value, like if we got here 15 or something, then what we have to do? We have to continue iteration. Okay, we have continued to the next iteration, and for the next iteration, we have to change our Medoids, one of the Medoids again. Maybe this time we can change the M1, like we can consider the M1 0 as the M1. Okay, 0 as the M1 on that case, and so it will not be M1 on that case. And again, we have to determine the distances, and then based on the distances, assign the members to the different clusters, and then find out the cluster cost, and then compare the cost with your previous iteration's cost. If it is increased, stop. If it is decreased, then continue. So in this way, we will find the clusters of basic K-Medoids algorithm. Is it okay? Is there any question?
Sir, did we discuss any solution for the disadvantage of K-Medoids, like about not finding the optimal Medoid?
Yeah, that's the major drawback. Okay, not finding the optimal, and we can also find out the optimal. That's what I want to say now.
ও আচ্ছা, এখনো ডিসকাস করা হয়নি এটা। ওকে।
So how can we find out the optimal solution in K-Medoids algorithm? Okay, in K-Medoids algorithm, we can find out the optimal solution, but on that case, the cost will be very high. That means it is expensive. It will be expensive, and on that case, each and every elements, or you can say every instances, one time we have to consider as the Medoid 1, and another time we have to consider as Medoid 2. So that means each and every element. So we are swapping now. Okay, every time just we are swapping one cluster. So in this case, we have to swap again and again, and each and every member one time we have to consider as there is Medoid 1 and also Medoid 2. If we consider that is for all combinations, then that is we will get then we need to search which of the combinations will give us the minimum cost or minimum clustering cost. Okay, the clusters we got, the clusters that will induce the minimum cost, that will be our optimal clusters. So it means what we have to do, we have to we have to actually introduce two flags. One flag for M1, that is Medoid 1, and another flag for Medoid 2. So another flag for Medoid 2. So two flags, we have to introduce two flags on that case. Okay, like in this case, initially we assume that uh, 9 is our Medoid. Okay, 9 is Medoid 1. So that means on that case we have to assign 1 to this flag, and 4 is our M2. Okay, so that means we have to mention here that the flag in M2, that is we have to on the flag of M2 in case of 4. In our next iteration we swapped the that is M2, and we swap it to 7. So that means 7, now we can see here 7 is considered as our M2. Okay, so that is, you can see here the 1, M2 is 1. The flag of M2, we have to set 1. And after that, maybe we can say, after that, we can swap the M1 to 0. Okay, so that means M1 say 9 to 0. So 0 is what? 0 is our F1. That is M1. Now maybe next iteration we can consider that there is the 4. The 4 is our M1. This one is our M1. Maybe the next iteration. So on that case, we can see that previously M1 serves as the M2. Now M1 we considered as our there is 4 we considered as our M1. So in this way, each and every element of this data set, we have to consider that this one is M1 and also M2. M1 and also M2. And besides that, we have to determine also the cost of each and every combination. Okay, and finally we will get the optimal clusters. That is the combination which returns the optimal cost. So that will be our output of K-Medoids, that is optimal clusters. But as I already mentioned that for this it will be expensive in terms of complexity, because if we have a large data set, each and every member of that element we have to consider the Medoid 1 and Medoid 2. That's difficult. And also not only the 2 clusters, sometimes maybe we need to form 5 clusters, sometimes we need to form 3 4 clusters. Then each and every one we have to consider as the Medoid 1, Medoid 2, Medoid 3, Medoid 4, Medoid 5. Okay, so that's expensive. Okay, so those are the limitation of K-Medoids. Then firstly, the basic K-Medoids algorithm, it will not generate the optimal solution, it will generate only an optimal solution. If we want to get the optimal solution, then the complexity will be high. Is it clear now?
Yes, sir.
Okay, thanks all of you for joining this session. So that's all in our K-Medoids clustering algorithm. Thank you very much.
Thank you, sir. Assalamu alaikum.
Alaikum salam.
Sir, can we discuss regarding our pre-thesis meeting?